Hey guys, today I'll be teaching you what binary algorithm is, and I'll also be showing you the implementation of this algorithm. Okay, so binary algorithm is basically efficient search algorithm. It is used to find a certain element. For example, in this case, we have an array. Now as you can see, this is a sorted array. Binary search can only be applied on a sorted array. Okay, so here we need to find whether the key, excuse me, whether the key 78 is present in the array. Okay, so we need to find out whether the element 78 is present in the array or not. Okay, so yeah, so what binary search does is it finds in logarithmic time frame whether the element is there in the array or not. Okay, so first step in the binary search algorithm is we define two integers, low and high. Low is the first index of the array, which is 0. High is the last index of the array, which is array size minus 1. Okay, so why is array size minus 1? Because we are starting from 0 and the ending index is 9. So array size is 10 and ending index is 9. So array size minus 1. Yeah. Yeah. And we define one more integer, which is mid, which is low plus high by 2. So it's mid of low and high. Yeah. Yeah. Okay. So first, initially mid will be 0 plus 9 by 2, which is equal to 4. 0 plus 9 divided by 2. Okay, so which is 4. So mid is 4. Now what we do is that we check whether our key is the fourth element or not. So we can see that 21 is not equal to 78. So next step what we do is that whether we check whether our key is greater than the mid element or less than the mid element. So clearly key 78 is greater than 21. So what we do is that if our key is greater than a middle element, we increment the low from 0 to mid plus 1. So now low will be equal to mid plus 1, which is 4 plus 1, 5, and high will remain the same. Okay, so now low is 5, high is 9, so mid value will change. 5 plus 9 by 2, which is 7. Yeah, so now we again check whether our key is the 7th element. So we can clearly see that it's not 55 is not equal to 78. So now key is greater than the mid element. So what we will do again, we will increment the low to high to mid plus 1. So now low is equal to mid plus 1 is 9. Mid, so now again we calculate the mid is 8 plus 9 by 2, high is equal to 9, we didn't change high. 8 plus 9 by 2, which is 8. Okay, so now we see that our key 78 is equal to mid element, and since we got this, we return the mid element. Okay, all right. Okay, so let us take another case. Let us say that now the key is minus 29, which is the 0th element of the array. Okay, so then again we start this same way. Low is equal to 0, high is equal to array size minus 1, mid is equal to low plus high by 2, mid, which is 4. So now we see that the key is now less than AR of less than for the fourth element. Minus 29 is less than 21. So in this case, as I said earlier, high will be mid minus 1. We won't change low, but we'll change high to mid minus 1. So here high will be 3, mid will be 0 plus 3 by 2, 1. Now again, as we see that our key minus 29 is less than the first element, which is minus 12. So again, high is equal to mid minus 1, which is 0. Now mid is equal to 0 plus 0 by 2, which is 0, and as you can see, the key is equal to 0 is equal to 0th element, which is minus 29. We found it, so we return the mid. Okay, so let us look at the implementation of this search technique. So the return type of the function is int. Let's name it as binary search. We'll take vector as an input. We are taking it a reference, and we take the key as another input. Okay. Yeah. So as I said earlier, we define two integers. Low is equal to 0 and high is equal to arr dot size. If you are not familiar with the functioning of vectors, then it's no big deal. We just took a vector is basically an integer array. It's basically an array, and we took an array as an input, and yeah, and this function what it does is returns the size of the array, which is 10 in our input. Yeah, and high is equal to array size minus 1. So now we define a while loop while low less than equal to high. Now we define another integer mid, as I said earlier, which is equal to low plus high by 2. Okay, so if arr if key is equal to arr mid, then we simply return mid. Key is less than arr mid, then we change the high value to mid minus 1. Keep the low value as same. Else we change the low value as mid thing. We and after the whole loop is iterated, if we don't find the element, then we return minus 1. Minus 1 basically tells us that the array size didn't return any. So fine. So in the main function, I have just taken the integer array as input, and I take the key as input, and we call binary search and store its value to this integer answer ans basically. Yeah. And we say that if answer is equal to minus 1, printf element not found, else printf element found at this index, which is answer. Okay, so let's run this function, see whether it works or not. Okay, so it clearly shows element found at index 8, or 78 element is found at index 8. What if the element was minus 29? So it shows that element found at index 0. What if we input an element which is not in the array, let's say 1? Element not found. Okay, so now we'll look at the limitations of binary search. So basically, if in the array there is an element, same element at two different indexes, and our key, and we need to find the same index. We need to find, let's say we need to find 0 here. So it will return that element is found but it will return either of these two elements, 2 or 3. It could return 2 or it could return 3. In this case, if you will check it out, it will return 2. So yeah, it will definitely show that the element is there in the array, but it won't show that it is present in two of the indexes. It will just show that it is present at index 2. This is one limitation of binary search. Yeah, okay. And another limitation is that okay, so what if the array was not sorted? The initial array that we take as input is not sorted. So let's say that this is our array, and clearly this is not sorted. So what we need to do is that we need to include this library. This is algorithm library. It us in using the sort function. So the sort function basically sorts our array. I just wrote the code for sorting the array. So now it will sort our array, and the sorted array will be this, and our key is 29 in the input. So it should give element found at index 0, 1, 2, 3, 4. Let's see we get or not. Yeah. So you can see that it is showing element found at index 5. So the time complexity of binary search algorithm is big O of log into the base 2. It's because in each iteration we divide the array size in half, because if key is greater than the middle element, we exclude the first half of the array. We take low as mid plus 1. So we just take the other right half of the array, the bigger part of the array, later part. Okay, and if key is less than middle element, then we take the first half of the array. Yeah, so basically we are dividing the array size in two in each iteration, so log into the base 2. Yeah, and the space complexity is big O of n, where n is a size number of elements in the array, basically to store the array. Yeah.